Test, test. 1, 2, 1, 2. Yeah. Cool. Right, good evening, everyone. Welcome to my talk, Sniffing API Requests, Man-in-the-Middle Attacks for Fun. This is a little talk which is kind of inspired by a blog post that I've done. But this talk adds a bit more context and a bit more information, and I think it's a bit more interesting than the blog post. I'll preface this by saying, if you do find vulnerabilities in other applications, you are legally meant to tell them about these vulnerabilities. I'm not prompting you to go and look for things. It's up to you to be above the law and to do the right thing. So who am I? Just doing a little introduction. So I'm Oscar. I'm 26. I'm a full-stack engineer at a women's health startup. So I'm working on a team where we're building a React Native app at the moment. Building a period prediction app as well. We've got a bunch of node.js microservices. And we've actually got a period service as well, which is really cool. So there's, I've been straight on periods for the past 3 months, but it's really cool, really interesting. We love TypeScript front to back. I am originally an industrial controls engineer. Used to work a lot with robots on production line installations and all that. But I just got tired of the old languages, and I just decided that I want to try the new stuff. So I made the jump to web. But I do hold on to that old engineering part. I do contract in Antarctica, and I was there for 3 months earlier in this year. And I was writing code for 6 remote weather stations across the plateau, as far as 400 kilometers into the continent. And that was really cool. But there's nothing scarier than deploying a code onto a remote weather station. You can't rerun a Terraform deployment out there. It's just plug it in and then go and just pray that the data's coming through. But luckily they're still running, so that's all good. And I think I don't know if this is true, but I think maybe I could be the first person to have deployed Node.js in Antarctica. I don't know if that's true. I'd have no way to verify this. But it's still running at the moment, and that's cool. And that's another talk for another time. And yeah, my first web app got me a cease and desist from the National Crime Agency. That's another story for another time. Okay, a native app is no more secure than a web front end. And this isn't news to most of you, I'm sure. But during the whole AI, LLM, ChatGPT wrapper era, there were a lot of people that were building products, building applications, and not really having much of a foundation in app development. So naturally, they're building fast, and they're putting these keys, which should be private, bundled into the native app. Which, if you're building for web, this is bad practice. But I think people can be a bit more lenient with native apps because they think, people aren't going to decompile the binary or whatever. But yeah, they will. And it's actually quite a fun thing to do. But yeah, this goes without saying, don't put API keys on client devices. So let's just go a little recap of structure of an application. You've got a front end, which could be a web front end. You've got a native app as well. These communicate with an API layer by HTTP requests or whatever request you're using. And then this API layer is talking to external services, be that a database, other microservices, something. But the idea is that this, behind the scenes, is all private. You can't see what's happening here. There's no way to see, there should be no way to see what's happening behind the API layer. Which leaves this not secure layer where you can see everything. And it's just how applications work. And it's something that we have to deal with. And we try and secure this as best as we can using JWT tokens, auth credentials, something to prevent this, this bad actors doing what they're not really meant to do. So this is what we're targeting today. This is what I'm sort of going through. So yeah, let's sniff some API requests. So this is the general setup of when you're accessing the internet from your device. So you're going to be on a network, on your home network, and your device will request request a connection to a domain. The domain is resolved to an IP address, and then you ask your router, you're like, hey, what's this? Where do I connect to this IP address? Router then looks around the network. If it can't find the IP address, then it'll ask the internet, go via ISP, and then return you the data. And that's all happy and all works normally. But this is where we're going to put a little device in between. So what we're doing is we're setting this man-in-the-middle device as a proxy for all of the requests coming from this target device. So we do have to modify some certificates within the device in order to make this go through SSL certificates as well, so you can have full visibility on HTTPS requests, and the device doesn't know what's going on. But the reason why this isn't easy to kind of install in a malicious way is because you do need to meddle with the device quite a bit. And it's all my own stuff, all stuff that just fun to mess around with. And in this talk, we're going to look at the app Bereal. If you don't know what Bereal is, it's like this social networking app that instead of posting whenever you like, it tells you when to post, and everyone is told at the same time. You get a notification saying, time to take a picture, and you're meant to be real, right? It's real life. And this is why I kind of wanted to target this especially, because I thought, they're trying to be, it's trying to be representative of real life, and I think it'd just be funny to, make it a bit fake. So I plugged this in, did this setup for a bit, and just used the app and just saw what was going on. And I could see there were three URLs that were hit quite often. One of them was the Firebase storage domain, and this is used for uploading files, which in this case is always images because it's an image platform. Second one was a Cloud Functions domain. And this links to creating posts, deleting posts, anything that's related to post management tended to go through this endpoint. And the third one was a mobile.bereal.com. There's another endpoint used to get posts, feed, view friends, and add friends. Now, what I think they've done here is that Firebase is known to be extremely expensive in production. It's really good to build little things, but when you're scaling, especially to what Bereal has done with their millions of users, it can be quite expensive. And I reckon what they've done is they've added this mobile.bereal endpoint, because this is getting pinged the most. Like, it's polling this constantly to get feeds friends, which returns a JSON of your entire feed. So what I reckon is they've got kind of a caching layer, maybe a second database within this mobile.bereal, so they don't have to execute functions on every request, because that would just be crazy. So just to test it out, I copied the bearer token from the request, and I managed to make just the normal feed request. So this is response with a whole JSON array of all your friends, what their pictures and where their latitude, longitude, just the normal stuff. And then another one that I copied was just the set caption post endpoint, which just allowed you to set unlimited captions. So that was an initial quick win, but this is just sort of scratching the surface, because really what I wanted to do was do custom image uploads. Like, this is the core of why I was inside the Bereal app. I wanted to know how I can put my own images, not go through the camera and do all this. So we're going to be following the trail of a Realmoji upload. Now, if you don't know what a Realmoji is, it's basically an emoji, but it's a picture of your face. And you take it in the moment. It's meant to be in the moment and real. So the reason why I actually decided to follow this rather than just making a post is because you can send a Realmoji as much as you like. There's no limit on it, which is good from an analysis point of view. So I can see, I was sending out a lot of Realmojis that day just to sort of understand what's going on and understand the process of actually uploading this to their servers. So first of all, an initial post request is made to the Firebase Storage API saying, hey, I want to upload a photo. And then it's responding with an upload ID, and then instantly your client device is saying, okay, well, I'm going to send you the data now, and it sends a put request to another endpoint. I think it might be the same endpoint, actually. And then that image is uploaded, responds with the image URL, and then the final one is you make this, execute this cloud function, which adds a Realmoji. You're basically just saying what the Realmoji is, link to download the image that I've just uploaded, and all the information about it. And then that appears as normal, and then that appears as a Realmoji. So a total of 3 requests are made to send a Realmoji reaction. So this is what I wanted to intercept. So this is a little demonstration of what's going on. Pretty standard operation, I think. Just request, and then send the data, and then the final send of the Realmoji. So this is what I want to intercept. So I pause this request, and then I change the binary body of this request to the image that I wanted to send, and I got a 400 error, which is really annoying. But the cool thing is that if you look at the message, it says, cannot finalize upload. Current size is 616,334, expected final size of 45243, which is really helpful actually, because they haven't just made up this number. They're not guessing how big my image is. Like, I've told them this at some point. That is definitely going to be somewhere. So with a little control F, I found that actually on the initial request, I had specified the file size, which I should have known, but there we go. So I needed to intercept both requests in order to actually upload my custom image. So I did that. I found the XGOOG upload content length, and I just changed that to my custom value, and then did the next step as normal, and there we go. And then I could send a normal, whatever picture I want. And it's exactly the same for posts. So it was, after doing this, you could instantly just make a post, and it's no different really. And then comes automating. So this Mitten proxy, which I was using, they do have a Python API, which is quite handy. So you can literally write a custom code to handle the request. So like, for example, I've just got the same code here. So we have, I know. So we're looking at the upload type. We're checking the metadata to see if it is going to be a real emoji or if it's going to be just a normal image upload. And then we're also changing the XGOOG upload content length to whatever image size that we have on our device. That's pretty handy. So this is good fun for about 5 minutes. But it's not just Bereal though. The thing is, it's like, this is the thing that we have to deal with when we're building applications. This is just a normal fact of life, that just API requests can be a bit problematic, especially if you're building on something like Firebase, that it's very client heavy and all the logic is driven by the client unless you want to spend loads on these cloud functions and stuff. So it's not really an ideal platform to build these kind of things. But we all love e-bikes, don't we? And there's this company in London who's been made aware, but they had this endpoint which you could ping with, you normally need to ping with a latitude and a longitude, the bounds at which you want to see the bikes. But I found this is unlimited. So here I am, I'm putting the entirety of London, and you can see I get a request, car ID 1 of 7,914. So this returns every single e-bike in London, no authorization header, just straight up, just the request. And then I put this on a little map box just to get a visualization, and you can see like all of the bikes, just straight up all of the bikes, which is crazy. Now I did some probing on this just to see if this would actually show bikes that are in use. I thought that'd be really cool to just see where they're going and stuff. But they did have some security measure where they wouldn't show the location of bikes that are currently rented. But you can see the exact location of all the bikes that aren't being used. You can see the price for each bike. I didn't even realize they had different prices, but there we go. You can see the reservation state, all without an auth token, which isn't really ideal. Now, what they could have done better with this, straight off, they could have limited the search radius. This is something they could easily have done. Like, assume that, okay, no one's going to want to see all 7,800 bikes from an unauthenticated client device. But and also only allow searches from authenticated users, having the token, just they have that traceability. And I think these measures just aren't that difficult for them to introduce. But if you're building something fast and trying to get to market, it's worth thinking about if a problem is worth solving, because not every problem is worth solving. So I'm going to finish off with the hot take. So if you have something that can be exploited, you really just need to assume that it will be exploited and just evaluate how crucial that exploit may be. It's like changing captions on images. It's not really very crucial. And intercepting the API of an image sharing app, it's just like really, that's not really going to affect your market necessarily, unless there's some third-party devices that are being sold and stuff. But you can cross that bridge when you get to it. But then again, live tracking data with no authentication, that it can be pretty crucial. So require auth tokens for everything, unless your application won't work without it. And stay away from Firebase for serious applications. So thank you for listening. Follow me on Twitter if you want. Don't have to.